Hello, everyone. Like the title says, I would like to talk about how to test a property. It might sound a little different, but I think it's a very interesting topic to talk about. And yeah, going forward, before everything, I will give a little intro about myself, then talk about my experience at Tremor, and give a brief about different types of testing and how testing is usually done, what are the trade-offs, and what can be the best approach for your use case. And then I would like to talk about property-based testing and why it would be one of the good choices available, and also back it up with a concrete example, how I tested a custom language made by people at Tremor called Tremor script, and how it is tested using property-based testing. And at the end, I would like to conclude with my learnings and uh, yeah. So about me, I am Rohit Dandamudi. I recently graduated from college and I'm currently working as a web software engineer at Glens. Just before graduation, I was looking to explore different technologies, and then I uh, got to know about CNCF and how they have different projects. And while going through different projects, Tremor got my interest, mainly because it was completely out of my expertise, not expertise, like my interests in general. I just wanted to explore, and Tremor had this nice use case as well that we're trying to solve. And they're also one of the subsets in CNCF itself, one of the few Rust projects in CNCF. And yeah, and also it is one of the sandbox projects there, meaning it's still in its early stages. So I thought I could grow with the community and learn more about it. So those were my initial motivation. That was my initial motivation. And how was my experience? I think the 3 months that I worked there, it was completely different. I learned about different paradigms, different thought process, and uh, how to how to collaboratively write different things and how to learn things which is completely out of your comfort zone. So yeah, that was my experience. And coming about testing, right? Testing in general, from what I've seen over the years and how people write tests, it's usually pretty much predefined, and people know what happens with the test and what they can expect from the test. And also the test cases are pretty standard. Like you give very few. Right. I think it's pretty much limited to the by the person who's writing the test cases or the tests. And also, writing more tests usually doesn't mean you're writing you're maintaining your code better, or you have a better quality code. That's one thing that I learned. You can easily write tests which pass, but doesn't correlate to having good code. And other thing that I got to know is that after a certain percentage, it really is diminishing returns for the effort that you put in for writing tests. That's what I've seen. Like after 99, or for that last 1%, it really takes a lot of effort, and the output is pretty much limited. So yeah, and coming to different types of testing, right? There are tons of testing, how you can test your code or anything. So the different types, for example, like unit test, integration test, end-to-end test, UI test, property-based testing, multiple testings, right? So I thought this graph actually helps give a nice outlook of how what these tests are trying to accomplish, and what two parameters are required. Like fundamentally, any test is written basically to see if they are feature compliant or they cover enough input scope so that the tests are cover all the edge cases, right? So for in cases like unit tests and UI testing or QA tests, it's basically pretty much concrete. You're testing something which you already know, and that follows exactly the feature that you're trying to test it on. And also there's this randomized testing, right? Like fuzzy testing or monkey testing, which give completely random inputs, and which which may break your code or something like that, but it doesn't actually test the feature that you're testing. It's not particular to one feature. So property-based testing somewhere comes in between of these two. I think it has nice balance of both. Fundamentally, it tests the property, so I think it really has that feature thing in, and also it has the automated testing as well, which gives different inputs and covers various edge cases. So more about property-based testing. It has multiple features, and also it's a good framework to use. And QuickCheck is the original library which implemented this approach and which was actually written for Haskell to do property-based testing. And shrinking is one other feature which I think many agree that makes property-based testing very desirable. As the name suggests, shrinking, it basically shrinks any failing edge case to a much simpler case, so that you can easily figure out where your test is failing and you can make changes accordingly. I think it's a good feature to have. So the big question is, can it be used everywhere? It looks like it has everything perfectly done. So no, like I said, there are different trade-offs for every test involved. And in the beginning itself, if you go and write property-based testing for your code, property-based test for your code, it doesn't make much sense. And also, for many cases, there might not be exactly well-defined properties to test on. So yeah, it's really about your use case and uh, how it works out for you. On that note, I would like to talk about current use case where I use property-based test to test Tremor script. So a little context about property-based testing and what is Tremor script in Tremor script and what is going on here. So a little more about Tremor script. It is a custom-made language by people at Tremor to write small code to write functions or to handle the software easily. Although it's not the primary focus of their efforts, but it's a nice feature to have which makes everyone's life easier. So Tremor script, testing Tremor script is not a priority, but it should be one of the things to be done. So that's one of the reasons why property-based testing really helps, because you don't really have to spend a lot of time to test your software. And other thing is a language has a lot of features inbuilt, and languages usually have different things. Like anything, it can be written in any way, but fundamentally it has different features. And knowing the creators can really help jot down the important properties and write it easily. So these two are really good reasons to choose property-based testing for Tremor script in particular. So coming to how it is done and how property-based test is achieved in Tremor script. Usually, here we are testing it using Erlang. So we're using a new framework, or not a new framework, but uh, we're using a framework called EQC. It is the Erlang's version of QuickCheck. And yeah, so Erlang QuickCheck is, you can easily access it. It's available. So how exactly property-based tests are done, or how is it structured? These files can give help a little more to understand how it is structured. So the EQC part itself is implemented in these 6 files, and although PBT and util files are not really important, they are mostly supporting header files. The gen script is where actually the structured code that we test against is generated. So this is where we get the exact syntax that we're trying to test. Test against, and the model ERL has the native Erlang implementation of it. So we are testing both of them, and the test EQC part is where the actual property is written and where the testing happens. And spec ERL is where the EQC functions like generators and shrinking is done. So this is where whenever you get an error, the shrinking happens, and as well as which function to call to generate different input types. The randomization and the shrinking features are done here. In this picture, you can see how how everything is connected, right? How what feature or what property that we're actually testing. Here it's called simple expression. So the property is any simple expression present in Tremor script. We're kind of testing it. And we check whether each part of the expression we generate an AST, and we check whether we generate an AST using the generator functions, and then we check against two implementations, the REST and Erlang implementation. I think it's a good property to check on, especially here, because fundamentally every language should return similar outputs, although it's not entirely the case every single time, but that's what usually happens. So one such example which helps, I think, which is complex but also a good case to explain property-based testing, is the patch feature or the patch operation in Tremor script. So a little bit about patch operation. It is a patch, it's an operation on expressions or basically on records. Uh, Basically it can be anything like merging or something similar to that. So if you can see the structure, patch operation usually follows this syntax. There's a patch keyword and an expression following that, and off, and multiple patch operations, and end. So usually that's how a patch operation is written in Tremor script, right? It can be different in different languages, but here this is how it is done. And coming to how the gen script file is written. So basically, as you can see, the different functions with the same name, gen underscore, and based on pattern matching and how you give the input, this particular function gets called. If you give these three as input, those are the patch keyword, the expression, and the patch operation. So next, as you can see, different the structure and different operations are kind of generated here. The patch keyword in the beginning. After that, we recursively call the gen function again inside the gen function to call. It can be anything, right? It can be nested loops or anything. So we are covering different cases here, and this is what is happening. And at the end, we're also making sure that the respective patch operation is uh, kind of separated, and all the patch operations are present. And then if we see about model.erl, here also we can see that's a very similar case. And the AST eval function is which the again we are using pattern matching here, and eval function is basically we're evaluating the AST, and again we have similar input here. But here what we're trying to achieve is we're trying to implement it similarly in Erlang itself. So as you can see, we have written an anonymous function here, which basically matches to whatever key that you have. So based on the operation, or based on which operation that you're doing, uh, that particular call is done, and that particular operation is done. As you can see above, there are different patch operations that are done. So insert, merge, upsert, and erase. So depending on which patch operation is present, these are called, and similarly, the expression is built here. That's how it is done. And at the end, we fold everything. That's a feature in Erlang. We fold everything and we return that. So after that, this is the last and this is the most interesting one. That is the spec ARL. Here, as you can see, here is where, like I said, you get the randomized input or the shrinking feature, right? So what we similarly generate all this five operations. On top of it, we can see which particular uh, feature is tested against, right? Whenever you run property-based test, this particular property-based test, based on a frequency function, we give weightage to each operation, and they get called randomly with random inputs, and then they test it against the uh, code or the property, that is model .erl implementation and the REST implementation, and see if both kind of have the same structure, right? And yeah, The shrink feature here, if you can see the question mark shrink, is the one which actually cuts down your edge cases when they fail and gives you a much simpler case of errors. And the record or the operation here itself is unary operation. If you have the chance, go to the file and you can see that it's a very big file and has multiple features in it. And this one in particular is for unary operations for a record. Patch is one of such operations, and we are kind of working on top of it. So that's pretty much it on how to test a property and how to structure your code and how it is implemented in a functional programming language. And yeah, coming to my learnings, I think it is more about approaching things incrementally. If you see batch operation, right, it has multiple sub operations in itself, like merge, insert, and upsert, right? And these itself had to be tested before implementing patch, because it made it very easier. You can reuse the code and you can incrementally move on to the next feature. Uh, the first the first test that I wrote was on arithmetic operations. Even that kind of helped me write the patch operation test, because you can add, subtract, and you can do multiple operations on strings and records and something like that. So if you do fundamental things first, at least that's what I've seen here, it kind of helps a lot when you move forward. So the incremental approach is very useful. And uh, coming to other thing is learning about trade-offs. Trade-offs can be both technical or the time that you have, and it can be on anything. Like you have to see which approach or which tool or which software helps you accomplish your task. Here, it really made sense to use property-based test with the time constraint and with the amount of effort that we are trying to give. And similarly, other places it might change depending on the team and how well it can be used. And coming to other thing is about I learned about functional programming, basically functional programming and systems languages and CNCF. This was another really good thing that I got to know. I think, and also it also reinforced my interest in open source. I think open source is great, and I really encourage everyone to take part in it if you have the time. And yeah, that's pretty much it. With that, I think I would like to conclude. If you have any more things that you want to discuss or if you want to talk about it, you can reach out to me in LinkedIn or Twitter. That's where I'm most active at. And or you can also read this blog that I wrote, which talks about the same thing that I did here. Uh, yeah, you can go through that. And yep, thank you for the opportunity.
And that concludes the third talk, which makes this halftime in our TremorCon. First of all, big thank you to Rohit here on my right. That is joining us now for some Q&A. You still have time, if you have any specific questions, to put them in the chat and we will address them. Otherwise, we'll just go over some things. Let's start with quick introduction. Rohit, tell us
Yep.
a word or two about yourself.
Yeah, sure. Like you already heard in the talk, I'm Rohit. I recently graduated, and currently I'm working as a software engineer. Before graduated, I wanted to explore different technologies, and that's how I got to know about Tremor and the whole experience. And yeah, that's it about me.
So you picked probably the most exotic mentorship project in the history of mankind. Your project was involved 3 languages, didn't it?
Yep. Yeah, first I thought it just involved Lang for the most part, but actually the task itself was testing a language itself, so that included another language, and also the implementation was in Rust, so total in all, it involved three languages, and I had to learn everything from scratch. Yep.
Yeah. Um, what made you mad enough to do that?
Mostly because after you leave college or any educational place, you don't have that much time to explore, because you kind of are you are set, you're set to do some things and you have to do them, and almost your work will become your life, and after that you just want to rest. You don't want to learn new languages, which are hard. I think so. I thought before graduating, and open source has always been a good learning experience for me. There are people kind enough to share their knowledge, so that was the primary motivation. Yeah.
That's a good one. Do you regret it having to learn three new languages?
It's both, I guess. Mostly because I shouldn't have taken such a huge learning curve project in my final year of graduation. It would have been much more fun in my first or second year because I had more time. In final year, it would more priority would be to your next thing, your job or higher education or something like that. And this although affected me like in a positive way. I got to learn new things and I understood how to learn something which is out of my comfort zone. But on a practical or job market point of view, these skills are highly, I mean, very, very narrow, very niche. Not many people got to know, at least ask for these skills. But the process itself made me learn how to learn. So that's, I think, is important. Yeah.
Yeah, but the languages were just like a sideline to your actual project, wasn't it? It was primarily about property-based testing.
Yeah. Language was just a tool to express the logic and everything, how everything is connected. But uh, all in all, the core functionality was property-based testing, which I think I wouldn't have ever done, even in my whole career. I think in future also, not sure. Probably it might include in the future now. But before before the project, I don't think there was something called property-based testing or how it is done, what are its use cases where it can be used and how it can be used. This kind of led me to broaden my knowledge. Like there are a lot of pure technical technology related things that can be explored, and different problems can be solved through different tools. It's a matter of choosing the right tool. Yeah.
That's a really good insight. Um, in the whole path of the 3 months, what would you say was the biggest hurdle, the biggest obstacle you overcame?
The biggest, I think, it's implementing the project, like from a description to actually writing the code and writing it the right way, because we can start it anywhere we would like, because that list of tasks were in bullet points, we could have started anywhere. But going in a particular order and making sure our future selves are also like taken into account while implementing things, that I think was something initially it was hard to learn, because I was only set out to the particular function or the particular code that I had with me. But as I went on, I understood, okay, there are a lot more things to consider. It's not just my task or yeah, my job. Yeah.
So, taking this as a bit of a segue for the next question, um, if you would start again, or for anyone who starts a mentorship project or anything, what would be your number one advice for them or for your past self?
I think don't get intimidated is the first thing I would say, because the whole process is there to help you. Everybody is there to help you. Nobody is there to do something or expect so much out of you. The only motivation should be to learn, and I think you will get it if you really want to learn. There's so much to learn. So I think that's the main thing one should focus on. No, don't get worried about the little things like what is happening. Am I doing good enough or something? Just focus on doing better than what you are before.
That's wonderful advice. So you got to learn a lot of new technologies: Rust, Erlang, QuickCheck, Tremor script. Did you enjoy this combination of technologies, or was it something where you think, "Oh God, those Tremor people picked something really horrible"? And you can be honest, it's only
Yeah,
recorded.
in the
Um,
beginning, I'll be honest, it was like, what are these technologies? Why are they even using it? They can use something very simple, right? Why are they using Erlang? Why are they using so many like outdated things? At least for me, I thought it's very out. From my
you're
experience.
hurting my heart, Rohit.
No, 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 no,
But
no,
it's okay.
no.
I'm just
Yeah,
kidding, please.
it's not like it's outdated from my point of view because I didn't had that much knowledge. Even I didn't know much about Rust, to be honest. So now I got to know about the ecosystem, how helpful it is, how much thought process goes into implementing things, and they're actually much superior in many cases. Actually, depends on how we use it, but yeah,
That's a good one. And don't worry, I was just kidding.
yeah.
um, so, and this is something that's not visible on the uh, surface. Part of your task was actually implementing the interpreter for Tremor script, or part of the implementer for Tremor script in Erlang. Um, well, what did you take away from that? Was it something that you thought you would do in a 3 months mentorship? Was it something you enjoyed? Was it something you'll do again?
Mm, I think I definitely enjoyed. It was an interesting experience because the most accessible technology to me was only web development. That's the only thing I could have done from watching tutorials and
Mhm.
doing things. This was like doing an interpreter, contributing to an interpreter that is actually working and solving big problems. I think that's not at all accessible, at least for a student, unless they're doing some internship or at a very core team of the company.
Mhm.
Nobody would get that access. So I think that was more. I'm fortunate, I think, because I hadn't had this opportunity in my 4 years of my undergrad. So it was a good way to end my undergrad. Good way to learn new things and end it on a high note. Yeah.
Yep, that's that. So we only have a few more minutes left. So we'll have like one last question for you. And you touched on this a bit before, but let's make it formal. You learned about new testing my voice is already broken. Testing methodologies, mainly property-based testing, incremental testing, all of those. While you might not use them in your everyday job, do you plan on advocating for them? Do you think they are a good fit for things outside of a interpreter, and it's something you plan, given the opportunity, to do again?
Yep. I think property-based testing in particular, if you have a lot of features or a lot of unexpected things to test on, like if you go through a unit test approach, I think it really makes sense. If you just define a property, it can be any property, right? It's up to you. And if you define it, as long as it is right in the fundamental level, it works in all the test cases. You don't have to worry about the edge cases and everything. So I think it's not just limited to an interpreter or a very niche market. I think it's more than that. Also, property-based testing, there are implementations in other languages also. It's more accessible than one might think. Uh, so yeah, definitely. If it's in early stages and if they have the use case, I definitely think property-based testing makes a lot of sense. Yeah.
Awesome. And so, last but not least, a minute for you to talk about what you're working on, anything you want to share, anything interesting where people can follow you, can see what projects you're into at the moment. Stage is yours.
Sure. So currently, I'm mostly going back to web development again. I'm doing web development and focusing on that. But I'm also like exploring software development in general in a broader level, seeing it in a higher level. Apart from that, I intend to do some projects that are always left in GitHub. But yeah, you can always reach out to me on Twitter or GitHub or LinkedIn even to collaborate or to discuss more on this. I'm always available there. Those are the only three platforms that I use. And yeah, also I would like to explore more things, I think, if possible, especially the Kubernetes ecosystem. I'm part of CNCF, but I'm not sure. I'm not much sure about Kubernetes.
That's
Yeah.
totally fair. The CNCF is a beast.
Uh,
Well,
Yeah.
Rohit,
Yep.
thank you so much for your wonderful talk and for the time you spent with us on the Q&A. We really appreciate it. Thank you 1,000 times.